Hello everyone, and let's continue solving some problems about work and energy. We will revise this chapter using these problems. Now, question number 11. A steel ball that has a mass of 3 kilograms is attached to a rod of negligible mass and is raised a vertical distance of 0.25 meters as shown to the right, and it is released from rest. If air resistance and friction is negligible, so we have no more energy losses, which of the following can be correctly applied to determine the speed of the steel ball when it is at its lowest point B? Well, actually, this is a very straightforward question. It's asking me which of these concepts can I use to determine the speed of the ball just when it reaches this point or location B right here. Can I use the conservation of momentum, conservation of energy, kinematic equations for constant acceleration, or Newton's first law? Well, it's clear that we will be using the conservation of energy equations or laws to answer this question. Next question, 12 to 14 are related. The next graph shows kinetic energy as a function of time for a cart moving in a straight line on a tabletop. So we have kinetic energy and we have here time. The cart is momentarily at rest at the end of which interval? Well, at rest means that it's not moving anymore, so the velocity is equal to zero. When the velocity is zero, this means that the kinetic energy is also equal to zero. So where is the kinetic energy equal to zero? We can see it is at the end of zone A. So we can say at the end of interval A. Next question. The speed of the cart is constant through which interval? Well, constant speed means constant kinetic energy. At which interval is the kinetic energy constant? Not either increasing or decreasing. It's clear that it is through interval D, so the answer here is going to be D. Again, why? Because the kinetic energy is neither increasing or decreasing, it's the same. So this means that the speed is also constant. Next question. Which of the following quantities has a magnitude of 0 throughout interval B? So this is interval B. We can see that the kinetic energy is increasing. This means that here, kinetic energy in this zone is increasing. This means that the velocity is increasing. And the velocity can never increase unless there's acceleration. So which of these quantities has a magnitude of 0? Let's see. Is it the speed of object? No, it's not the speed of the object, because if the speed of the object was 0, the kinetic energy would also be 0. The acceleration of the object, we said, because the object is increasing its speed, because it's increasing its kinetic energy, there must be acceleration. The net force on the object, well, that's also not true, because there wouldn't be any acceleration if there wasn't any force. If you can remember, we can say that the force is equal to the mass multiplied by the acceleration. And since we do have acceleration and we do have mass, therefore we do have a force. And finally, none of these quantities has a magnitude of 0. So it's clear that none of these magnitudes have a value of 0. Next question, 15 to 17 are related. The sketch below shows the path of a heavy iron ball thrown by an athlete. The ground is level and the dashed lines are parallel to the ground. Assume that the frictional forces acting on the ball are negligible. This means that we have no energy losses. Well, it's very similar to the first question we solved in the previous video. Now it's saying that the speed of the ball at point I when it leaves the hand of the athlete is the same as the speed at which point? Well, we said because here it will gain kinetic energy, then it will start losing its kinetic energy, and here it will gain mainly potential energy, then it will start losing its kinetic energy again, etc. At the same height, it will have the same kinetic energy. So this means it has the same speed. So we can say here is similar to here. So let's see our choices. And the answer is clearly D, which is point 4, okay, or location 4. Next question, the potential energy of the ball is greatest at point. Well, it's very clear that it's the highest point of the path, which is point or location 3. So the answer is B. And finally, which of the following statements is true about the acceleration of the steel ball during its flight? Some of you may say that this is not directly connected to this chapter, and I can say yes, but it's very easy to answer because in a projectile motion, we will have a constant acceleration because the potential energy is calculated using the equation, which is equal to m, g, h. And g, which is the gravitational acceleration, is constant and doesn't change throughout the path of the ball. So we can say that the acceleration is always the same throughout the path of the ball. Here we solved about 17 questions that helped us revise the chapter in total. I hope this chapter was one of the easiest, just like I see it. And I hope that all of you understood this chapter very well. See you in the next chapters. We will be covering the whole exam material for the ACT exam, so stay tuned. Subscribe to the channel so you can see the videos always.